We'll now look at sine substitution. And first, we'll kind of set up the idea of what we want to do with these trig substitution problems. Let's consider my circle of radius 1. And let's suppose I want to find the area of this circle using calculus. I can solve for y and get 1 minus x squared. So to find the area, the easiest thing to do would be 4 times the integral from 0 to 1, since this is a quarter of the circle, of my function. And currently, we have no idea how to evaluate this. However, if I let x be equal to sine theta, that means dx would be the derivative, which is cosine theta d theta. This now becomes 4 times the integral of the square root of 1 minus sine squared theta. And then this dx becomes cosine theta d theta. I can use some trig properties and say that this is the same thing as the integral of the square root of cosine squared cosine theta d theta, which is 4 times the integral of cosine squared theta d theta. And we do know how to evaluate this. So we went from an integral that we can't evaluate to something that we already know how to do. So this is essentially the setup. We're going to want to do this kind of trig substitution, in particular the sine substitution, anytime we see a squared minus x squared, where a can be any number. And in this case, what we'll do is we'll let x be equal to a sine theta. This means that when I substitute back in, I end up with a squared minus a sine theta squared. So this gives me a squared minus a squared sine squared theta. I can factor out an a squared and get a squared times 1 minus sine squared theta, which we know using our trig identities is cosine squared theta. So I can turn this a squared minus x squared into an a squared cosine squared. Once we are going to integrate this, we're going to want to substitute things back in terms of x. And to do this, we'll have to really think about what trig functions are. If I have my angle theta, sine is opposite over hypotenuse. And in this case, x was equal to a sine theta, so sine theta is x over a. So we have our opposite and our hypotenuse. The Pythagorean theorem then gives the last side is a squared minus x squared, and then we take the square root. And we'll have to use this triangle to substitute things back in. Let's try this example. I do see the a squared minus x squared, so I'll let x be equal to 2 sine theta, which means dx will be 2 cosine theta d theta. The numerator, dx, is now 2 cosine theta d theta. And the denominator is the square root of 4 minus 4 sine squared theta. Well, this becomes 2 cosine theta, and simplifying the denominator makes it 2 cosine theta. So this is just the integral of d theta, which is just theta plus c. We do have to substitute back in. If I think of what x is, I can then solve for theta. We know that x minus 2 is sine theta. So theta is arc sine of x over 2 plus c. A second example, we have the integral of 16 minus x squared over x dx. And once again, we can see this a squared minus x squared. So I'll let a be equal to 4 sine theta, which means dx is 4 cosine theta, d theta. The numerator is then the square root of 16 minus 16 sine squared theta. The denominator is a 4 sine theta. And then dx is 4 cosine theta d theta. Once we simplify the numerator, we get 4 cosine theta over 4 sine theta times cosine theta d theta, which is equal to the integral of, extra 4 in there, 4 cosine squared theta over sine theta d theta. We now need to figure out how to integrate this, and we're going to use a few trig identities to figure it out. Well, cosine squared is 1 minus sine squared. And then from that, we can actually split this integral into 1 over sine, which is cosecant theta, minus sine squared over sine, which is sine theta, d theta. And now we can actually evaluate it. The integral of cosecant is negative ln of cosecant x plus cotangent x. And the integral of sine is negative cosine, so we have plus 4 cosine theta. Sorry, these are not x's, they are thetas. Plus c. We now have to think of our triangle, and remembering that we let x be equal to 4 sine theta. So x over 4 is equal to sine theta. If I have my triangle, sine is opposite over hypotenuse. And then the last side will come from our Pythagorean theorem. Cosecant is hypotenuse over opposite, so 4 over x. Cotangent is adjacent over opposite. So there we have the square root of 4 minus x squared over x. And then cosine is adjacent over hypotenuse. So we have 4 times the square root of 4 minus x squared over 4, and then plus c. We can then simplify this slightly. This is 4 plus the square root of 4 minus x squared over x. And then here I just have the square root of 4 minus x squared plus c. So now I have my final answer.